Okay, we want to talk about section 8.4, divergence test and the integral test. So let us look at this divergence test first. Okay, now what is a divergence test? All those tests are for series. Okay, so the question right now is that given a series, so summation a sub n and from 1 to infinity, how do we know? Is there a condition that can guarantee that this is divergence? Okay, so is there a condition or something that guarantee the or that gives, maybe that's better, gives the divergence of the series? So that's the question, okay? Yeah, is there a condition that gives the divergence of series? All right, so let's think. So now I'm going to prove, okay? But let's think about it. What it means by convergence, okay? The meaning of convergence is the following. Namely, if I define S sub n, namely this is the nth partial sum, which is a1 plus a2 all the way to a sub n, then the series is convergent if and only if S sub, limit n goes to infinity of S sub n approaches to a number. Okay, limit into a number. Okay, so suppose I have a series. Suppose this series is convergent. What happened? Well, then if I follow this one, right? So if I define S sub n, which is a1 plus a2 plus an, right? And I also define S sub n plus 1, which is a2 plus all the way to a sub n plus 1, right? S sub n plus 1 means I add all these to the n plus 1 term. Then, because the sum, if the series is convergent, the sum is unique. So limit Sn, this is L by definition, but this should also be this guy, because this also means I'm adding this to infinity, all the way to infinite many terms. So this and this should be the same. Okay, this guy and this guy, same thing. But if that is the case, you see, I'm going to subtract S sub n from S sub n minus 1. Okay? Now, on one hand, this must be 0 because this L minus L is 0. But on the other hand, what is this? On the other hand, this is, if I look at the expression of S sub n plus 1 and S sub n, you see the difference is this A sub n plus 1. So I get this condition. This condition must be true if the series is convergent. If the series is convergent, then its nth term must go to 0. Okay. So therefore, I'm going to just write this as a thing, as a property here. Okay. So if A sub n is convergent, then, and this is just n plus 1 term. N plus 1 is, and I can change the index, so maybe this will be n. The limit a sub n must be 0. If the summation, the series, if this series is convergent, then limit of nth term must go to 0. Conversely, now this is important here. Therefore, if limit a n goes to infinity, if this is not 0, then this series is not convergent. That means it's divergent. And this is called the divergence theory, divergence test. Divergence test is this one. Is this one. This is called divergence test. And if you have the book, I can show you where it is. It is theorem. This is exactly the theorem. 8.8 on page 627. Okay, page 627. We have this test. So example. All right. I mean, immediately use it. I'm going to do example. Example. So given a sequence, say, 1.1 to the nth power, kth power, sorry, k from 1 to infinity. Of course, last time we talked about why this is not convergent. We used the geometric series to show that this guy is divergent. But if I look at this example of this guy, this theory, I can test on this. Because the kth term, this is infinity, it cannot be 0. Because when 1.1, when k goes to infinity, this goes to infinity. So it's not 0. So this series is divergent. Okay? Now I can give you another example that is not so obvious. So if I have, say, k squared plus 1, okay, 2k squared minus 3, k from 1 to infinity, this series. And the question is that, is this series convergent? Okay. Well, if I look at this, if I take a limit as k go to infinity, k squared plus 1, 2k squared minus 3, right? What is this limit? I can use a L'Hopital's rule, right? Because both of these go to infinity. Both of these go to infinity. So I can use L'Hopital's rule. So when k go to infinity, this is L'Hopital's rule is that you just differentiate both numerator and denominator respectively. So to cancel, right? K cancel. So this is 2. Well, 2 is not 0. So immediately the answer is this series is divergent right away, because its kth term doesn't go to 0. This is 2, doesn't go to 0. Okay? All right, let me number the page. This is 1. Today is what? 29? Okay. That's page 2. I can give you another example. Okay, yes. So how about this example? Summation sine, say, k pi. Okay, k pi over 2. right? K goes to infinity. I'm sorry, K from 1 to infinity. I mean. The question is that, is this convergent? Is this one convergent? Okay, so I just look at the nth term. Is sine. K goes to infinity. And I want to see what this is. Okay? But the problem with this guy is the following. Because it depends on what K is. So this will be, so remember, so what is sine of K pi over 2? Well, if K is like a 1, like 1, 5, 7, 9, 13, those numbers, then sine of pi over 2, K pi over 2 is 1. But if K is 2, even number, 2, 4, 6, 8, right, those numbers, even number, this is 0. And then if K is 3, 7, 11, those numbers, this is negative 1. Because when K goes 3, sine 3 pi over 2 is negative 1. So it's this. So the limit of the approach is what? Well, it's jumping around between those numbers. Okay, if it is odd number, but that odd number comes from 1, 5, 9, 13, and so on, it's 1. But if this case is even number, it becomes 0. If case 3, 7, 11, those numbers, it becomes negative 1. So this one, no limit. The limit doesn't exist because of this. So the answer is what? Okay, so therefore this series is divergent. Okay, so this is very powerful. If the limit of the nth term doesn't go to 0, then it's divergent. No matter what, it's divergent. So we have seen several examples. All right. Then we want to talk about, for this chapter, there's another thing called integral test. 3, 4, okay? All right, so we'll do examples later, right? Do exercise later. The next thing we want to talk about is integral test. Integral test, all right? What is an integral test? Also for convergence. Okay. So what is it? Okay, so suppose I have a series given a series. Let me call it A sub k, okay? K from 1 to infinity. Where I'm assuming A sub k is all positive. Okay? And assuming this is in a decreasing way, so A sub k plus 1 is smaller than A sub k. Okay? So this is decreasing. So each term is positive, but all the terms, but it's in a decreasing way. So when the index is bigger, if the index is bigger, the value is small. Okay? This is for OK. From 1 all to k. Okay? So suppose I have this. So, okay, so let me draw a picture. Okay. Keep in mind, my idea is want to see whether this is convergent. So if I look at this graph, okay, so before I go on, I'm going to define the function f in such a